Okay, this is a problem. We want to find out the lowest common ancestor of a binary tree. I think the most common method is to use a recursion function. Here we're going to use a queue, and we're going to traverse the tree and find out the lowest common ancestor. So let's first define a queue. And we also need to record the information of a node with its parent node. And we want to add have the parent of the root as null pointer. Add the root node into the queue. Then we can traverse the queue. And when should we stop? We should stop when we find we have both the P and Q in the map. So when we cannot find this P node, or we cannot find the Q node, then we continue to look for them. So we first pop up the node, remove it, and we want to check if this current has a left child, then we add it to the queue. And also record the information that the current node is the parent node, and do the same for the right child. Okay. Then after that, I think we have the map. So for the map, we want to define a set. So we want to find out all the parent node of P. We want to add the P into the map, into the set. Then all the parents of P node are in the set. And we're going to go through the Q node as well. If we can find the Q in the set, that is going to be our lowest common ancestor. Otherwise, stop. So at the end, if we cannot find anything, we just return a null pointer. Okay, let's go through this one more time. So first define a Q0 so in order to traverse the tree, define a map to store the information of its node and a certain node and its parent. For root, its parent is null. So first insert the root node. So you want to keep going through the tree when there's we cannot find we don't have this map including P, or when the Q is not in the map. But when both are in the map, then we can stop. We don't need to go any further. So we get the current node from the Q. If it has a left child, we push that into the queue and also record the child parent information, and same thing for the right child. After that, we have the map. Then we define a set. So for this set, we go through the P node, insert all its parent into the map. Then we check the Q node if we can, and we just go up along the Q node. When we can find the Q node in the set, that means it's the lowest common ancestor. For example, let's say P is equal to 6 and Q is equal to 4. So we know P's parent node is 5 and 3. So when we check, and that is saved in the set, when we go up along Q, we first get 2, it's not in the set, and we keep going up. When we get to 5 is already in the set, so that is what we are looking for. Okay, let's submit. This is correct. One more cases. Correct. Submit. That's it.